We are the Study Buddies. In today's mathematics section video, we are going to be learning about two theorems which are called remainder theorem and factor theorem. Okay, so let's begin. So let's first look at remainder theorem. So what remainder theorem is saying that if Px is a polynomial and C is a constant, then Pc equals to R. Which means that if we have a polynomial, let's say I have a polynomial of Px equals to x squared plus 2x plus 3. Let's say, for instance, if I have a polynomial like this and I have a constant C which I've obtained from this calculation, like from x minus c, the value of c is equals to x. So let's assume that c equals to 3, let's say. So if I substitute this 3 inside this equation, and the answer I'm going to get from this equation is actually similar to the remainder I would get when I divide the polynomial with this value. Okay, so I'm very sure you are not very clear when I explain this, but I'll use a few examples to make it clear. So look at this question: 2x power 4 minus x cubed plus x squared plus x minus 3 divided by x equals x plus 1. So let's solve this question first using synthetic division, then later I'll show you how the remainder theorem applies for this. So synthetic division, first step, from this we have to find out the value of x plus 1 equals to 0, therefore x is equal to negative 1. Okay, so now we are going to do synthetic division. Same, put something like that, then we are going to just copy down. So 2 negative 1 1 1 negative 3, and put negative 1 over here. So let's begin to solve. 2 times negative 1, negative 2. So you plus this, you're going to get negative 3. So if you want to understand more, please watch my previous video on synthetic divisions. 4, so it's negative 3 0. Okay, so as I've said before, how are we going to get the answer from this question is that the remainder is from the last number here. So in this case we can see that the remainder is actually 0. So rather than just doing this, what we can do to just find out the remainder is by using the remainder theorem. So let me show you how to do that. So in remainder theorem, we saw that the constant or the c value comes from this equation. So in this case, c is similar to, let's say, is x plus 1 equals to 0, x equals to negative 1. So in this case, c is equal to negative 1. So if you want to understand more, just watch the beginning. I've explained this just now. So c equals to negative 1. So according to remainder theorem, px is a polynomial, c is a constant. So if it's pc, then it equals to r. Okay, so now we have c value, which is negative 1. So by right, according to this theorem, if I take this negative 1 and I substitute inside this equation, I must get an answer of 0. So let's see if I'm getting it or not. If yes, then this theorem is correct. So whatever the mathematicians think was correct lah. Okay, so p negative 1 equals to 2 to the power of negative 1, 2 negative 1 power 4 minus negative 1 cube plus negative 1 square plus negative 1 minus 3. Okay, so let's begin to solve this. This one we're going to get 2, this one plus 1 minus 1 minus 3. So 2 plus 1 3, 3 plus 1 4, 4 minus 1 3, 3 minus 3 0. So this is generally the easiest questions involving remainder theorem. So now let's look at something much more challenging. So let's look at this complex example. So px equals to x to the power of 4 plus ax cubed plus bx plus c. So this equation divided by x minus 2 divided by x plus 1 and x plus 3, you're going to get remainders 44, 5 and negative 31. So if you divide by x minus 2, you're going to get 44, x plus 1 5, x plus 3 negative 31. So now you have to find the values of a, b and c, which is kind of challenging. So if I were to use synthetic division to find out one by one, I think it would be impossible. So what we have to do in this case is that we only have to rely on remainder theorem. So let's begin. So first let's solve for x minus 2. Okay, For x minus 2, we can see that the c value which we are going to obtain through this method is 2. So c equals to 2. So by right, according to remainder theorem, when I substitute this c equals to 2 inside this equation, I must get 44. So let's begin. So p2 equals to 2 to the power of 4 plus a 2 to the power of 3 plus b2 plus c. So if I expand this and I solve this, I have to get 44. So therefore, I'll bring it to the left hand side. 2 to the power of 4, I'm going to get 16 plus 8a plus 2b plus c must be equal to 44. So for this part, I'm going to get 8a plus 2b plus c equals to 44 minus 16. Answer is 28. So this is equation 1. So now let's move to the second one. So for x plus 1, the c value is going to be negative 1. Okay, so now I'm going to just substitute negative 1 inside the polynomial equation. Okay, so after solving this, I'm going to get an answer of positive 5. So therefore, if I bring this to the left hand side, the answer is going to be negative a minus b plus c equals to 4. Okay, and now 5, no, 4. So the third value of this one is I have to use this value, x plus 3. So x plus 3, the c is going to be negative 3. So p negative 3, I should get negative 31. So I'm just going to substitute this again as what I did for the previous examples. Negative 3 plus c. So therefore I'm going to get an answer of negative 27a minus 3b plus c equals to negative 112. So actually for these both, I've skipped the second line because I want to cut short the time. So from the equations above, we found 3 equations like this. So now what we are going to do is that negative 112. Okay, so what we are going to do now is that we are going to do simultaneous method, which means what I think is that I have to do equation 1 minus equation 2 first. So if I do equation 1 minus equation 2, 8a minus negative a, I'm going to get 9a. 2b minus negative b, I'm going to get positive 3b. c minus c is 0. 28 minus 4, 24. So since I can divide the whole equation by 3, I'm going to get 3a plus b is equals to 8, where b equals to 8 minus 3, 8. So I'll name it equation 4. So next I can also do equation 2 minus equation 3. So why I'm actually using elimination method for now is to remove the c values. So 2 minus 3, negative a minus 27a, I'm going to get 26a. Negative b minus negative 3b is going to be positive 2b. And for negative 4 minus negative 112, it's going to be 116. So I can divide this whole equation with 2, in which I'm going to get 13a plus b equals to 58, where b equals to 58 minus 13a. So now equation 4 equals to equation 5 because both are having b's. Okay, so 58 minus 13a equals to 8 minus 3, 8. So by solving this, you're going to get 10a equals to 50, a equals to 5. Okay, so since now you know the value of a, you can find out the value of b. by substituting inside this equation. So b equals to 8 minus 3a, 8 minus 3 times 5, which means we are going to get negative 7. Okay, so since we know values of a and b, now we can choose any one of this equation and substitute both values. So I'll choose this one, so which means negative a minus b plus c equals to 4. Substitute in negative 5 minus negative 7 plus c equals to 4. C equals to 4 plus 5 minus 7. You're going to get an answer of positive 2. So this is one of the most complex questions involving remainder theorem, but it's easy actually if you understand remainder theorem clearly. And so that's all for this video, guys. If you like this video, do like this video, comment if you have any doubts, share this video to your friends, and don't forget to subscribe and click the bell icon. That's all for today. Thank you, take care, goodbye.